Hi everyone, I'm Maruti, a partner engineering lead here at Google Cloud. In my role, I collaborate with our partners across our data analytics portfolio products to help our customers solve complex challenges using our joint products. In this session, we will dive into some of the most exciting advancements and announcements that we made in the last few days in Google Cloud's data analytics platform, which is BigQuery, and explore how you can build streaming data pipelines to unlock real time insights. Over the next few minutes, we will focus on leveraging multiple engines such as SQL, Spark, and Python on a single data copy in BigQuery. And this is a way for you to leverage your favorite language and framework. Managing diverse data types and open table formats like Iceberg, Data Lake, Hoodie for building flexible data lakehouse architectures, and deriving insights from images, documents, and audio files using BigQuery's BigQuery machine learning or the BQML feature. And finally, building real-time analytics pipelines to process and analyze streaming data as it arrives. And here is a visual representation or architecture diagram of four key layers or the concepts we discussed. And this shows how BigQuery has evolved to be the foundation of our data and AI world. And some of the key characteristics and features, or the top layer, is about the unified user experience for all data teams. And this is possible via the BigQuery Studio. And you have the AI assistance of the Gemini to enhance your experience while you are on the BigQuery Studio. It helps reduce friction in data to AI workflows and promote collaboration and governance across teams. BigQuery Studio expands on our SQL workspace, if you've been using BigQuery in the past, to be a one stop shop for all data practitioners. In BigQuery Studio, you only not get SQL editor, but also you get access to Python notebooks backed by our BigQuery DataFrames, which will touch base in a few minutes. And beyond this multiple language support, BigQuery Studio is a fully integrated development environment in a kind of an IDE that includes, source control mechanisms or functionalities, capabilities, and versioning as well. And at the bottom, you have this AI foundation layer, and Vertex AI plays a huge role here, which is a platform that can help you go from prototyping to production within the same platform. And BigQuery machine learning feature or BQML is a way for you to create and train models on top of BigQuery using SQL commands. That way, you can take advantage of all the auto ML features that are available in the BQML feature in the platform. BQML is also tightly or natively integrated with Vertex AI. That way, you can also take advantage of the foundation models or the Gemini models on top of the data that is sitting in BigQuery. That way, you don't need to move the data to take advantage of the foundation models and do generative AI use cases. In a way, you're bringing AI close to the data or close to the BigQuery. And these models, the Vertex AI platform, is built on advanced and high compute infrastructure or infra to support your demanding and robust use cases. And and Vertex AI as a platform has a feature called Agent Builder, using which you can build agents or generative applications in a low code, no code manner. And now the agent builder is also tightly integrated with BigQuery and Google Cloud Storage. That way, you can create generative AI applications such as search and conversations on top of your data, which is sitting in BigQuery and DCS with minimal configurations or minimal effort. And also, you get to take advantage of the Google's the enterprise grade security, networking, and infra capabilities. And one of the significant building blocks or the layer in this diagram is the unified data and AI governance. Data and AI governance is a critical consideration for many enterprises, irrespective of their use cases or applications or industry related use cases. And this has become even more crucial with the emergence of new use cases around generative AI. Dataplex plays a pivotal role in this governance landscape by providing a centralized discovery, a one stop for managing, monitoring, and governing the data and AI artifacts across your data platform. It provides a way to easily understand where your data is coming from and transform and the transformations it goes through undergoes with the end-to-end data lineage capabilities that are built into this product, Dataplex product. Dataplex also has capabilities like automatic data quality, which lets you define and measure the quality of data automatically at any point of time. And let's double tap on the multi-engine layer, which is so powerful. DataFrames. This is a new feature within BigQuery, which brings the power of Python together with the scale and ease of BigQuery with a minimal learning curve. If you're familiar with Python's open source Pandas for data manipulation framework, and scikit-learn or sklearn is the machine learning framework. So the BigQuery data frames implements the common APIs from both libraries Pandas and scikit-learn. So it's the same syntax or the same kind of experience you get by working with BigQuery data frames, but the difference is the compute and the storage is all happening on the BigQuery, and that way you can take advantage of the Python, the capabilities that you've been always familiar with, and also take advantage of the processing horsepower of BigQuery. And now Spark is becoming a de facto or a standard platform or a engine for enterprises to deal with their data workloads and AI workloads. And our auto scaling serverless Spark is a huge productivity boost for developers. With serverless Spark, developers can focus on code and logic instead of tuning the infrastructure and managing the clusters, right? The Spark clusters. And serverless Spark engine is directly available within the BigQuery Studio right now and allows you to process data as easily in PySpark as you do with SQL without the need to manage any compute infrastructure because it's serverless. It's you're taking advantage of the serverless in the background. And now Spark Store Procedures is another feature which is available within BigQuery that lets you wrap serverless PySpark in a SQL procedure that can be called from a SQL query. Now you can take existing Spark code and make it available directly from SQL with no additional infrastructure to manage, all with integrated security and governance within the BigQuery. That way you can create a Spark Store procedure and then create it and then share it with different team members or publish it for people to call it and reuse it as easily as possible. Now, BigQuery has this feature called Big Lake, which is the storage engine for lakehouse architecture. BigQuery lets you have a common way to work with the data, whether it's in BigQuery managed storage or the data stored in open table formats like Iceberg, Delta Lake, or Hoodie on cloud storage. So think of this BigQuery Big Lake as a way to unify your data lakes and data warehouse to achieve your lakehouse architecture. And we also support managed tables for Iceberg. This supports DML manipulation language and high throughput streaming. Everything is supported out of the box. And in addition to the open table formats, there is support for various file formats, including Parquet, Avro, ORC, CSV, and JSON. And constant innovation or evolution is happening in this open table formats because more and more enterprises or users are trying to take advantage of this open source open table formats to take advantage of um, benefits like schema evolution and such things that inherently available as part of this particular open table formats. And now, talking about the ingestion layer and the data processing enrichment layer, which can help you achieve your real time analytics, uh, and that is where PubSub plays a huge role. PubSub is a offering from Google Cloud, which is an asynchronous and auto scalable messaging service that decouples services producing messages from the services processing those messages. PubSub is used for streaming analytics and data integration pipelines to load and distribute data. PubSub is deeply integrated with Dataflow, which is built on top of Apache Beam, the open source unified batch and streaming pipeline processing engine. And this particular integration adds messaging and event ingestion to all the streaming capabilities of Dataflow. So you will mostly see, or widely see, people using PubSub and Dataflow as components sitting next to each other as part of their streaming analytics architecture or use cases. PubSub offers push-based delivery of messages as HTTP request to webhooks as well. That way, you can implement workflow automation using cloud functions or other serverless products. And PubSub, because it's a Google Cloud product, it has built-in monitoring and logging capabilities as well. And Dataflow, as we discussed, it's built on Apache Beam, and this is used for both batch and streaming pipelines. In fact, you can have a simple pipeline or single pipeline that can do both batch and streaming pipeline in the same pipeline. And Dataflow abstracts away the complexity of pipeline management by automatically automating typical manual streaming intelligence functions, making it highly automated and orchestrated. It is serverless with auto scaling and auto provisioning capabilities, which can support petabytes and exabyte scalability. Now, data engineers who wants to build pipelines using Dataflow can use multiple languages and notebooks or even SQL to create data, pipelines. And Dataflow ML, which is based on Beam ML, which lets you deploy and manage machine learning pipelines. This particular component or aspect can help you do both local and remote inferencing with your batch and streaming pipelines. And finally, Dataflow templates that you can create on top of your Dataflow pipelines allow you to easily share your pipeline with other team members and across your organizations, or take advantage of many Google provided templates. So if you go to the Google Cloud documentation, you can see all the Google Cloud provided templates, which caters towards different use cases, different products, because Dataflow can work with various products both on the source and destination side. And sometimes it can help you do bi-directional flow of streaming of data as well. And here is a stepping back and zoom out and think about a end-to-end architecture which involves different stages in the life cycle of data analytics. You can see that PubSub and Dataflow together can help you with ingesting and data processing or enriching enriching functionality. And that way, once the data is available within BigQuery in a real-time manner, you can build your business intelligence use cases or take advantage of the advanced BI use cases within BigQuery, and also the BQML capabilities to build your predictive AI, auto ML, and generative AI use cases as well in real time manner. And again, stepping back and talking about Dataflow itself, it's very easy to use. We have a Dataflow UI using which you can select the right template if you want to use the Google Cloud template, and then execute it. That way, you can at any point of time you have a way to figure out what is happening in the pipeline and also troubleshoot when you run into any issues. Now, this is a new, relatively new feature called Apache Kafka for BigQuery. And for people who are not familiar with Kafka, Apache Kafka, it's a distributed event streaming platform, which is open source, widely used by many enterprises. Now, Apache Kafka is managed on Google Cloud, which means it eliminates the need to worry about version upgrades or rebalancing and other operational headaches of you doing by yourself or deploying the OSS or open source Apache Kafka. And because this is managed and available now on Google Cloud, it comes with the out of box cloud monitoring, logging, and IAM, the identity and access management, and creates all deployments to be highly available by default. Apache Kafka for BigQuery is a secure out of box. It is integrated with and supports Google Cloud IAM, like we discussed, identity access management. And if your use case involves creating customer managed encryption keys, CMEK, you can do that as well, and also supports virtual private cloud. And finally, this is a relatively new feature. This is like just launched at Google Next in April 2024. And this continuous queries is a feature that can help you unlock continuous analytics processing via SQL. Previously, even when you are using streaming data ingestion, you would have to schedule periodic queries to process data as it landed. With continuous queries, you get the ability to run unbounded SQL queries, which continuously process the data the moment it arrives. It provides deep integration with Vertex AI, the other Google Cloud products like Vertex AI, Bigtable, and PubSub to further empower, all the data practitioners like data engineers, analysts, and scientists to develop more capable and event-driven applications like dynamic data enrichment and entity extraction with reverse ETL capabilities. That's one of the major features of this particular feature, where it helps you with reverse ETL capabilities as well. And then you can do things like AI-driven real-time anomaly detection and uniquely personalized content using your data in BigQuery. Now, using this power of these various technologies, you can facilitate real-time ingestion and processing or moving data to your BigQuery. And once the data is in BigQuery, you can take advantage of BQML and its native integration with Vertex AI to build your predictive AI and generative AI use cases, generative AI use cases, everything within the same platform. Thank you. And as a next step, I highly recommend you guys to go through our Google documentation where we talk about all these features, how to get started, and also some code labs for you to get up to speed with the usage on the Google Cloud platform. Thanks, everyone.